A very warm good morning to one and all. This is Maria Pushpam, and for today's class, we are going to see viscosity of gases. Before seeing that, viscosity of gases, I'll say what the problems based on mean free path. Is it okay? Then we can go with viscosity and the factors influencing viscosity and what are the main advantages of viscosity and problems based on viscosity. So these are things we are going to see for today's class. So first we can see the problem based on mean free path. Last class I have explained you mean free path and factors influencing mean free path. So I'll go with the problem first. Okay, so the problem is the collision diameter of a gas is 36.1 centimeter. The collision diameter is given as 36.1 centimeter, which is nothing but we say it is sigma. Calculate the mean free path of the gas at 25 degrees centigrade and 1 atmospheric pressure. So only three things are given. Collision diameter is given, then temperature as well as pressure. So here if you take the formula for and we need to calculate the mean free path. So what you have to do here is first you put the formula. So lambda is equal to RT divided by square root of 2 pi sigma square N0 P. Sigma square N0 P. So the sigma value is given here. It is 36.1 nanometer, which can be written as 3.61 in 10 to the power of minus 10 meter. 3.61 in 10 to the power of minus 10 meter. Then if you take Avogadro's number, we have studied already, 6.023 in 10 to the power of 23. It's a constant value. And pressure 1 atmosphere is nothing but 1.01325 in 10 to the power of 5 nanometer Newton per meter. It's not nanometer, I'm sorry. Newton per meter. And temperature is 25 degrees centigrade, which can be written as 25 plus 273, which is nothing but 298 Kelvin. So I'll repeat the things given here. So pressure is given as 1 atmosphere, which is nothing but 1.01325 10 to the power of 5 Newton per meter. And sigma value, that's collision diameter, is 36.1 nanometer, which can be written as 3.61 10 to the power of minus 10 meter. We can make all the things in meters standard, okay. And Avogadro's number is 6.023 10 to the power of 23. And temperature is given degrees centigrade. We have to convert in Kelvin. So 25 degrees centigrade plus 273, which is nothing but 298 Kelvin. So you substitute all these values in the given formula and we get the answer as 70.58 nanometer. 70.58 nanometer. You can cross check it. Okay. So next I'll go with viscosity of gas. So all of us know what is viscosity. For example, I'll say a simple thing. உங்கள் எல்லாருக்குமே விஸ்காசிட்டி விஸ்கஸ் லிக்விட் இதெல்லாம் தெரியும்னு நினைக்கிறேன். நம்ம பார்த்தோன்னா you can take a liquid. Simply you take water, then we can take oil. If we make them both of them to flow parallelly in two tubes, what happens there is the flow of water will be very fast because it doesn't possess, it has a very low viscosity. அந்த திக்னஸ் பார்த்திங்கன்னா ரொம்ப குறவாக இருக்கும். இஸ் இட் ஓகே? அதெல்லாம் தண்ணி நீங்கள் ஊற்றினோன்னா ஓடி வந்துடும். பட் இஃப் யூ டேக் ஆயில் கீ, இஃப் யூ டேக் ஆல் தோஸ் திங்ஸ், தே ஆர் செட் டு பி விஸ்கஸ். அது ஹைலி விஸ்கஸாக இருக்கிறதுனால ஃப்ளோ வந்து ரொம்ப ஸ்லோவாக இருக்கும். ஸோ திஸ் வி கால் இட் இஸ் viscosity. Is it okay? This is what I am saying is for liquid, and also gases possess the property called as viscosity. Now we are going to see, because we are studying about gaseous state molecules, now we can see what is the property of viscosity possessed by gases. So viscosity is a characteristic property of fluids, which is nothing but liquid or gases. Okay, so normally if you take molecules of gas move in layers at different speed. எல்லா மாலிகுல்ஸ் வந்து ஒரே ஸ்பீடில் போகாது சரியாமா. ஸோ டிஃப்ரெண்ட் ஸ்பீடில் போகும். ஸோ ஒவ்வொரு ஸ்பீடில் போகிறவங்க இப்போ ஸ்லோவாக போகிறவங்கெல்லாம் சேர்ந்து ஒரு லேயராக போவாங்க, ஃபாஸ்ட்டாக போகிறவங்க இன்னொரு லேயராக போவாங்க. ஸோ தேர் த மாலிகுல்ஸ் இன் அ ஸ்லோ மூவிங் லேயர் ட்ராக் தி so molecules of gas move in layers at different speed. I'll repeat. So molecules of gas move in layers at different speed. So the molecules in a slow moving layer drag the movement of the molecules in the fast moving layer. ஸோ எல்லா கேஸ் மொத்தமாக போயிட்டுருக்கும்போது ஸ்லோவாக போகிற மாலிகுலர் லேயர் என்ன பண்ணுன்னா ஃபாஸ்ட்டாக போகிற மாலிகுலை போக விடாமல் மெல்ல அதுக்குள்ள ஸ்பீடு ஒரிஜினல் ஸ்பீடு இல்லாமல் கொஞ்சம் ட்ராக் பண்ணி விடும் ஸ்பீடை. திஸ் காசஸ் அண்ட் friction, internal friction or resistance between the adjacent layers of the gas moving at different speed, and this we call it as viscous force, viscous force. Is it clear? So I'll repeat the thing once again ma. So viscosity of gas பார்த்தீங்கன்னா உனக்கு viscosity of liquid அழகாக சொல்லி கொடுத்துட்டேன். ஸோ அதே மாதிரி கேஸஸும் viscosity possess பண்ணும். ஸோ கேஸில் இருக்க மாலிகுல்ஸ் என்ன பண்ணுன்னா சிலது ஃபாஸ்ட்டாக போகும், சிலது ஸ்லோவாக போகும். ஸோ ஒவ்வொன்றும் தனித்தனி லேயராக போயிட்டுருக்கும். மெனி லேயர்ஸ் வில் பி தியர். They form a layer and they'll be moving. So what happens there is the slow moving molecules in the layer will drag the fast moving மாலிகுல் லேயர். அதை ட்ராக் பண்ணும்போது என்ன ஆகும்னா ஒரு ரெசிஸ்டன்ஸ் வந்து எக்ஸிஸ்ட் ஆகும். ரெண்டு இப்போ ஒரு ஃபாஸ்ட் மூவிங் லேயர் ஒரு ஸ்லோ மூவிங் லேயர் இருக்குன்னா ரெண்டு பேருக்கு இடையில் என்ன நடக்கும்னா தேர் எக்ஸிஸ்டன்ட் resistance between the adjacent layer of the gas moving at different speed, and this we call it as viscous force, and this is given by the formula F is equal to eta AC divided by D. Eta AC divided by D, where A is the surface area of the layers, C is the difference in velocity between the layers, and D is the distance between the layers, and eta is the coefficient of viscosity. Eta is the coefficient of viscosity. I'll repeat ma. So the viscous force is given by the formula F is equal to eta AC divided by D. இதில் பார்த்தீங்கன்னா eta வந்து coefficient of viscosity, A வந்து surface area of the layer, C is the difference in velocity between the layers, and D is the distance between the layers. So if we put the value of A, C and D as 1, we get the value F is equal to eta. F is equal to eta. So you substitute the value for A is equal to 1 centimeter square, C is equal to 1 centimeter per second, D is equal to 1 centimeter in the above equation. So what you get there is F is equal to eta. So now we can define the coefficient of viscosity is defined as the force per unit area required to establish a unit velocity difference between two adjacent layers of 1 centimeter apart. புரியுதா? ஸோ உனக்கு எப்போ வந்து விஸ்காசிட்டியும் coefficient of viscosity ஃபோர்ஸ்க்கு ஈக்குவலாக இருக்கும்னா how we can define is viscosity coefficient is defined as a force per unit area. ஏன்னா நம்ம A வேல்யூ என்ன போட்டோம் 1 to establish a unit velocity difference. velocity difference எவ்வளோ இருக்கணும், ரெண்டு லேயர்ஸ்க்கு இடையில் 1, and the between the two layers is 1. Is it okay? So if so, we can say velocity is equal to force. Okay, so viscosity is equal to force. So viscosity coefficient may be defined as a force per unit area required to establish unit velocity, and the difference between the two adjacent layers of the gas is 1 centimeter apart. Okay, now I'll say the units of viscosity. If it is said to be a CGS unit, the unit is pies, and SI unit is called as Pascal second, and 1 pies is equal to 0.1 Pascal. Is it clear now? So it can be expressed in two units, CGS unit as well as SI unit. If you are expressing in CGS unit, we call it as pies, and if it is a SI unit, we call it as Pascal second. Okay, so now we can see the factors responsible are influencing coefficient viscosity eta. Okay, we have somewhat two things. First, we can see effect of temperature. Is it okay? I'll say two parameters are influencing. In previous case, if you take this mean free path, we have seen molecular size, temperature and pressure we have seen. But if you take this coefficient of viscosity, it is influenced by two things. We can see the effect of temperature as well as effect of pressure. First, we can see effect of temperature. The variation of viscosity with temperature is expressed by Sunderland. As he has given a correlation. Eta is equal to eta 0 into square root of t divided by 1 plus c by t. Square root of t divided by 1 plus c divided by t. Where eta 0 and c are said to be constants, and the constant c is called as Sunderland constant. The constant is called as Sunderland constant. So if you take this Sunderland equation, if you see, eta is directly proportional to square root of t. Eta is directly proportional to square root of t. So this peculiar behavior is due to the fast transfer of momentum from one molecule in one layer to molecules in the other layer. It's directly proportional. Is it okay? So the peculiar behavior is due to the fast transfer of momentum of molecules from one layer to other layer. Is it okay? So this equation is very useful. And next one, we can see the effect of pressure. Is it clear now? Yes? Okay. So effect of pressure. Under increased pressure, more molecules are available to transport the momentum from one layer to another. But mean free path is reduced, hence only few molecules can transport the momentum. And the two effects will balance one another, so viscosity is independent of pressure. விஸ்காசிட்டியில் உனக்கு என்ன டேர்ம் இல்லை, ப்ரெஷர் டேர்ம் இல்லை, ஒத்த லைனில் நம்ம சொல்லிடலாம். திஸ் ஹாஸ் நோ கார்லேஷன் வித் ப்ரெஷர். இஃப் யூ இன்க்ரீஸ் ஆர் டிக்ரீஸ் த ப்ரெஷர், viscosity won't have any change. But if you decrease or increase temperature, it will have some effect. But if you increase the pressure or decrease the pressure, no effect will be there. The reason is, under high pressure, more molecules are available to transport the momentum from one layer to another layer. But the mean free path என்ன ஆகிடும், is reduced. mean free path வந்து குறைஞ்சிடும். Hence only few molecules can transport the momentum. So the two effects will balance one another. So viscosity is independent of pressure. Okay. So next one, importance of viscosity measurement. நம்ம viscosity measurement எதுக்கு பண்ணுறோம் இப்போ பார்க்க போகிறோம். ஓகேம்மா? So importance of viscosity measurement. The measurement of coefficient of viscosity of gases provides a convenient method for calculating the value of collision diameter. It is used for calculating collision diameter, and the formula is eta is equal to 1 by pi sigma square n0 into square root of RTM divided by pi. And from this we can write the equation as we can take sigma up and we can make this to go down, eta. So sigma square is equal to 1 by pi eta n0 into square root of RTM divided by pi. And this equation we call this Chapman equation. Viscosity measurement is very useful because it is used to calculate the collision diameter directly. Is it okay? And the equation correlating this viscosity coefficient and your mean free path is collision diameter as well as coefficient of viscosity is given by the correlation, and the equation is called this Chapman's equation. So this equation is very useful for calculating the collision diameter directly. Is it okay? So these are things we have seen for today's class, and now I'll say a problem correlating this equation. With that we can wind up. Okay, ma. So at 15 degrees centigrade and 740 millimeter pressure, viscosity of carbon dioxide gas is 1.72 into 10 to the power of minus 4 pi s. Calculate the collision diameter of carbon dioxide. This is a question. I'll repeat. So the question is, temperature கொடுத்துருக்காங்க. Temperature and pressure are given for carbon dioxide, and the value is found to be viscosity value is found to be 1.72 10 to the power of minus 4 pies. We have to calculate the collision diameter of carbon dioxide. So if we take this problem, we can use this particular formula. Sigma square is equal to 1 by pi eta n0 into square root of RT divided by RTM divided by pi. So eta value is given. It is 1.72 into 10 to the power of minus 4 pi's, which can be written as 1.72 10 to the power of minus 5 kilogram per meter per second. Kilogram per meter per second. The reason is 1 Newton is equal to 1 kilogram per second and 1 Pascal is 1 Newton per meter square. If you are substituting all the values, we can get the final value as instead of putting 10 to the power of minus 4 pi's can be written as 10 to the power of minus 5 kilogram per meter per second. Okay, and n0 value I have said you 6.023 10 to the power of 23 Avogadro's number, and temperature is 15 degree. It is added with 273 to get Kelvin, so it is 288 Kelvin, and the molecular weight of carbon dioxide is nothing but 44. Because we are writing kilogram per mole, we can put it as 10 to the power of minus 3 kilogram per mole. So you substitute all these values in the above equation, we get the final answer as 17.79 into 10 to the power of minus 20. That's the answer for sigma square. Okay, so if you find the square root of that, we get the final answer of sigma, that is collision diameter. Sigma will be equal to 4.2 10 to the power of minus 10 meter. Is it okay? I'll repeat the problem once again. So temperature is given, pressure is given, then coefficient of viscosity is given, and the collision diameter is being asked. So if these things are given and if collision diameter is asked, we can use the formula, Chapman's formula, that is Chapman's equation. Sigma square is equal to 1 by pi eta n0 into square root of RTM divided by pi. Okay, now what you have to do is you take and write all the values given. So eta is 1.72 10 to the power of minus 4 pi's. We have to convert it into meter. So what you are doing there is 1.72 10 to the power of minus 5 kilogram per meter per second. And Avogadro's number is 6.023 10 to the power of 23 n0. And temperature is 15. So if we convert it to Kelvin, it is 288 Kelvin. And molecular weight of carbon dioxide is nothing but 44 into 10 to the power of minus 3 kilogram per mole. And if you substitute all these values, sigma square will be equal to 17.79 10 to the power of minus 20. And if you take the square root, sigma will be equal to 4.2 10 to the power of minus 10 meter. So we can have a short recap of the thing what we have seen for today's class. Very simple things I have taken today. So the first one is a problem correlating mean free path, and the equation used there is lambda is equal to RT divided by square root of 2 pi sigma square n0 p. Okay, and we have seen what is viscosity of gas and the factors affecting viscosity. Two things, effect of temperature as well as effect of pressure. Effect of temperature has effect, but effect of temperature doesn't has effect because it is cancelled. And last thing, we have seen the importance of viscosity measurement. The main importance is used to calculate collision diameter, and the equation is called as Chapman's equation. Based on Chapman's equation, we have seen a problem. Okay, thank you for listening. Continue studying. Thank you, ma.